Welcome back. Today, we're diving into a masterclass explainer on a truly fascinating question. How do we actually prove what makes us sick? Well, we're going to look at an incredibly powerful scientific tool called the Cohort Study. We've pulled together slides straight from a comprehensive professional epidemiology lecture series to really break down how this whole process works. Let's get right to it.
Here's our roadmap for today's explainer. We'll start with the epidemiological detective, move into the anatomy of a cohort study, talk about moving through time, cover some challenges and biases, look at real-world impact, and finally, I'll show you where to get the full lecture.
All right, part one, the epidemiological detective.
Have you ever wondered how we really know what makes us sick? I mean, epidemiologists are essentially high-stakes detectives, right? Think about it. When a mysterious disease strikes a town, they're the ones rushing in on the ground, asking the tough questions. Who got sick? Who didn't? And what exact clues did they leave behind? They're looking for what the sick people had in common and what they were exposed to, which then becomes the absolute foundation for how governments and doctors protect all of us.
Moving on to part two, anatomy of a cohort study.
So the fundamental question a cohort study asks is pretty straightforward. Do people exposed to a certain risk factor develop a specific outcome more often than people who weren't exposed? Think of it like this. Imagine two identical twin cities. In City A, most of the adults smoke cigarettes. In City B, almost nobody smokes. If we just sit back and observe them for, say, 20 years without interfering or experimenting, just watching, waiting, and comparing, that is the absolute essence of a cohort study.
And here's a really cool historical tidbit for you. The word cohort actually comes from ancient Rome. It described a specific unit of soldiers who marched, fought, and faced the exact same experiences together on the battlefield. Scientists actually adopted this term way back in the 1950s because it so beautifully describes groups of people marching through time together, sharing a common characteristic or exposure.
Now, the absolutely crucial point is how we set this whole thing up. We've got to start at a clean baseline. Step one is identifying our exposed and non-exposed groups while every single person is still entirely disease-free. This is literally the only way to ensure that the exposure actually happened before the disease. It's all about establishing that timeline.
Next comes step two, the follow-up, which honestly is essentially a giant waiting game. We track both groups over months or even years and decades, carefully recording any health events as these people just go about their normal daily lives.
And finally, we hit step three, the end of our timeline. This is the outcome assessment phase. We tally up the results and count exactly how many people in each group actually develop the condition we're looking at. By simply comparing these counts, we can calculate the actual real-world risk.
Okay, part three, moving through time.
So how do epidemiologists actually manipulate time to get their data? Well, it breaks down into two main types. A prospective study is basically like watching a movie play out live. You start right now and look forward into the future, gathering highly accurate data, but man, it takes years. On the flip side, a retrospective study is more like reviewing old security tapes. You start now, but look backwards using historical, medical, or employment records. It's way faster, but you're totally at the mercy of how well those old records were kept in the first place.
Part 4. Challenges and biases.
Now, because diseases often have super long latency periods, these studies can quite literally take a lifetime. For instance, the famous British doctors study, researchers had to follow their subjects for a staggering 50 years. Just think about the grueling stamina that takes. It highlights the massive financial cost and the constant, nagging risk that participants might just drop out or get lost to follow-up over the decades.
Aside from just battling the sheer passage of time, researchers also have to fight statistical illusions. The biggest headache here? Confounding bias. These are sneaky outside factors that can make a totally harmless behavior look deadly if we aren't careful. For a variable to be a true confounder, it has to hit 3 strict criteria. It must be linked to the exposure, it must be linked to the disease, and crucially, it absolutely cannot just be a step in the causal pathway.
Let's look at an example to make this concrete. Imagine we're running a cohort study looking into coffee drinking and heart disease. The very first thing we have to recognize is that, historically speaking, heavy coffee drinkers are also way more likely to be cigarette smokers. Secondly, thanks to previous massive cohort studies, we already know for a fact that smoking definitively causes heart disease.
And finally, smoking obviously isn't the reason coffee would cause heart disease, right? It's not in the causal pathway. So smoking acts as the perfect confounder here. If epidemiologists don't mathematically adjust for smoking in their data, coffee is going to falsely look like the culprit for heart attacks, simply because it happened to be hanging out with the true killer. Crazy, right?
All right, let's bring it home with Part 5, Real-World Impact. Let's look at how this data literally changes the world around us. Consider this real-world scenario straight from our source materials. A school health authority wanted to investigate if promoting physical education in teenagers actually reduces depression rates over time.
So after following the cohorts, the study revealed a relative risk of 0.42. In plain, everyday terms, this means the active teens were 58% less likely to develop depression. The physical activity was incredibly protective, and the data proved that the exercise literally prevents cases of depression from happening in the first place.
And the public health implication here is just massive. You see, it's no longer just a gut feeling or a hunch that kids should play sports. A well-run cohort study provides the hard, undeniable evidence that policymakers need to mandate things like daily physical education or to invest millions in the school sports infrastructure because they know it will directly improve population health.
And finally, Part 6. Get the full lecture.
We've really only scratched the surface of this incredibly detailed professional lecture today. If you want to master the math behind relative risk calculations, learn how to critically appraise medical papers, or dive into even more historical case studies, I have some great news. You can actually download the complete PDF file of this lecture for free right now in our PayUp store. It's an amazing resource for anyone looking to take their understanding to the next level.
So I'll leave you with this. If you were an epidemiologist for a day, what real-world exposure would you track? Think about the mysteries in your own environment. What hidden links between our daily habits, the things we consume, and our long-term health are just waiting for a detective like you to uncover them? Keep questioning, keep observing, and thanks so much for joining me on this explainer.